Chapter 7. So we're talking about exponential functions. Okay, so on the top of your notes, I photocopied the last summary page for 7.1, and it's just explaining what an exponential function looks like. So these are the characteristics of it, and you're going to have to remember these. Not all of them, but when we have an exponential equation, it's going through 0 and 1. Okay, because if you think about what it would look like, this is what an exponential function looks like. It means the exponent is x. Okay, so our exponent is x. So if we ever had 0, I don't know how I just did that. If I had 0 as my exponent, what is the value of y then? 1. Because anything to the power of 0 is 1. So when I put 0 in for x, our value is 1. So exponential equations are always going to go through 0 and 1, unless they're shifted up or down, left or right. Okay, but our basic equation is always going to go through the point 0 and 1. Okay, so this is what an exponential graph looks like if it's increasing. It means it's starting, it doesn't cross our x-axis, it crosses through 0 and 1, and then it increases. Okay, so this one would be an increasing one. And, oops, that's kind of ugly, but this would be decreasing. The domain for our exponential equations is all real numbers because it just goes from the far left all the way to the far right. It doesn't end. Okay, and then our range, you'll notice it doesn't cross that y-axis. No, the x-axis, sorry. So it doesn't touch it either. So it has to be, so I said our domain is always xer because it just goes on. And our range means y has to be greater than 0, and then it just goes up and up, and we don't know where it ends. Okay, but it doesn't go past the x-axis. Okay, so then it has a y-intercept of 1. We said that already, and I told you why, because if we had a 0 for exponent, then that gives us the value of 1. So our y-intercept is always 1. And then it says it has a horizontal asymptote at 0. So that's what I was saying. It doesn't cross this line. So that's like a horizontal asymptote. It's not going to cross that. Okay, so those are all the key ideas that we need to remember about exponential equations. So example 1 says, graph each exponential function, then identify the following: domain and range, x and y intercept, if they exist, and whether the graph represents is increasing or decreasing, and where the horizontal asymptote is. Okay, so a lot of this stuff never changes. So we don't even have to graph to find out most of this information, because if I have this, what did I say the y-intercept always is? 1. Okay, so y-intercept is 1. Oh, another thing that I should have mentioned on this other page, if I can get back, if it's a whole number like this is increasing. It's an increasing. If we ever have an equation that's a fraction, that's a decreasing equation. So this one would make a decreasing picture, which looks like this one here, right? Okay, so now looking back at the question we just had, is this one increasing or decreasing? It's increasing because it's a whole number. So this would be increasing. We have a y-intercept of 1. What else did it ask us? Oh, where would be the horizontal asymptote? Where did I say? What's that? No, where did I always say it was? X equals 0, right? Horizontal asymptote. What else do we need to know? Is there an x-intercept? No, because we said it can't cross that x line, so there would be no x-intercept. And then what did I say the domain was? XER. And the range is what? Y greater than 0, right? Because it can't be below that line. Okay, but if we were actually, so we can find all this without even graphing it. Okay? We know about exponential functions. But if we were to graph it, all you're doing is making a table. So if I put, say I had a negative number, -1. If I had 4 to the power of -1, remember if I have 4 to the power of -1, if we follow our rules of exponents, that makes 1 over 4, right? Because it's a negative exponent, so you flip them upside down. So that would actually be a quarter. Say I put 0 in for x. 4 to the 0 we said is 1. So that's another point. Say we had our x is 1. 4 to the power of 1 is just 4. And say we had 2 as our next value. 4 to the power of 2 is 4 times 4, which is 16. Okay, so we just made a table by plugging in random x values, whatever we wanted. Okay, so if I was to graph this, my x is -1, and my y is a quarter, so it's way down here. 0 and 1, 1 and 4, 2 and 16. You'll notice it's like heading up like that. Okay, so if I was doing the next one, y is equal to a half x. We can answer all of these without even graphing it, but we can graph it afterwards. So what's the domain for this one? Come on. All real numbers. Again, right? It doesn't change. What's the range? It doesn't change either. Y has to be greater than 0. Do we ever have an x-intercept? Nope, because it doesn't ever cross the x-axis. So you'd say none. Don't say 0, because that means it's touching at 0. What's my y-intercept all the time? Yeah. Unless we're shifting left, right, up, down. All of this right now that I'm talking about is unless we're doing transformations. And then would this one be increasing or decreasing? Right, because he's a fraction. Okay, so this one would be decreasing. And if I actually wanted to graph this, all I'd have to do is make a table. And then I just pick random numbers. So say I picked -3. And then I'll pick -1, 0, 1, and let's say 3. Okay, so we'll stick with 2 maybe. It doesn't matter, but a half to the power of -3. So if we were to write that, it would be half to the power of -3. So we would flip that to make that power positive. So it would actually be 2 over 1 to the power of 3. And then the power goes to everything. So it would be 2 times 2 times 2, which is 8. And 1 times 1 times 1 is 1. So when we have a -3, we actually have an answer of 8. If we put -1 in there, so say this was -1, all I have to do is switch it. So do the reciprocal to 1. So 2 to the power of 1 is 1, and 1 to the power of 1 is 1. No, sorry, did I say 2 to the power of 1 is 1? 2 to the power of 1 is 2, right? So our value would be 2. 0. So to the power of 0 always gives us an answer of 1 no matter what. And then if we had half to the power of 1, we would still just have a half. And if we had half to the power of 2, would be a quarter. Okay, so if we were drawing this, we have -3 and 8. And then what did we have? -1 and 2. 0 and 1. And then 1.5. And then 2 and a quarter. So our picture would look like this. Sorry. Okay, example 2 says we have the picture and we want to make the equation from it. So they're saying, how do we make the equation? Example 2. So the picture kind of looks like this, and they have specific points labeled. -2 and 16. Then they have -1 and 4. And then they have 0 and 1. Okay, so if I was going to put those on a table, I'd have -2 and 16, -1 and 4, and 0 and 1. Yeah, so we want to find the C value. So looking at how those numbers go, what's happening to them? But yeah, so we know it's going to be a fraction. And what are they being divided by every time on the one side? 4. Okay, so it's going to be a quarter, right? Because we know it's a decreasing, it has to be a fraction. So that would be our equation.